smaller or larger than our sidewalk's index? Is 3 smaller or larger? My bad. And it will never be the same. Right? Why can't it be the same? Why will this number never equal this number? That needs to be a number. Anyone? What's this number represent? It's the index of what? It's the index of the sidewalk. And what does this number represent? The index of the closest gutter. So why can they never be the same? Why does this number never equal this number? Because you're never going to have a gutter with the index of the sidewalk, right? So the reason I'm asking this is just to make sure I know you guys are following more than anything, okay? So the index of the closest gutter is 3. That will never equal the index of your sidewalk, which is this guy. And so we're going to end up with either, if we do a x is smaller than y, we're going to end up with a true or false value for whether or not the gutter is left or right of our sidewalk, right? So it's left of the sidewalk. With this particular function, it'll be true. And if it's the right of the sidewalk, so I'm going to go and grab this sidewalk now and move it again. We get false. Okay? That's gonna give us instructions on which direction to rotate the cross angled for our sidewalk. So if we were making something that was 1 in 40, we need to angle it that way, or we could actually do it. Do you want to do it as do you want to do it with geometry, or do you want to do it with trigonometry? Do you want to do it with vectors or trigonometry? Vectors? Okay, well that's easy. So if I want to make a vector that's 1 in 40, we can do that really simply. Let's actually grab a vector. The y value will always be 1. And the x value is going to be a kind of 4. No, it's 40. There. What am I doing? It will always be 40. So if I go display this particular vector, there it goes, 1 in 40. Hey, look, I was pretty close with that angle. As in, it's almost a mirror. Nice. I feel like I'm finally naturally drawing 1 in 40 ramps. Okay. Now, with this particular code here, I've drawn a line and I've set its length to be 4 because that's going to be the width of our sidewalk. But if I say, hey, let's just use this vector and make it 4 meters long, we're actually not going to get the response we're looking for, okay? Because when people set out these syntax, like these sections, they don't consider the actual physical length of a thing. They only consider what its length is in plan orthogonally. And there's actually a really interesting idea behind this. If I said, hey, what is the area of Australia, and Australia might be a bad example, but if I said what's the area of Australia, the measured square kilometres that you would use to calculate that is not considering three-dimensional geometry. Yeah? So a lot of the time when you actually work with urban planners, they very rarely actually look at 3D geometry at all. They just work on a flat plane or on a flat sphere. Because obviously the Earth is curved, right? No one here's a flat earther? Good. So we're on a flat. They work in 2D basically. Whoa! There's people in here. What am I getting at here? So there is actually just to let you know, and this you might find yourself doing this type of work in the future as well, because we know how to think in 3D, and for some reason they don't. If you're ever working on building a new town, or working out where you can build a new city, and like China does this a lot. China just goes, we want to build like a 1 million person city right here. Let's do it. Then the only time you kind of think about 3D geometry in that work is actually analysing the slopes of the landscape in the area, because basically people will avoid building any form of infrastructure if the slope's too steep, and so they'll just say, just ignore that. So you'll have to do analysis of saying, okay, this area here has an appropriate slope, that one's a median slope, and this one is a void, and then that analysis is used to actually then plan where you can put things. So that's just a useful thing to know that you might run into in the future. Okay, but where are we at? Okay, we're drawing a line from a point, and what we want to do is we're going to put an XY plane at the desired location, and that XY plane will be the thing that intersects our vector. Unfortunately, Grasshopper doesn't let you intersect vectors with planes. You're going to have to turn them into lines before you do that. So we've got a line. It doesn't matter how long that line is. We're treating that line as infinite, and we're going to intersect that line with that 4 meter plane, and that's going to tell us where the end point of our sidewalk is. So we've got a
curve is always vertical.
Pardon?
A curve is always vertical.
Curve?
So
Curb.
like it's not
Let's treat it as vertical right now. Okay? We're doing urban planning. This is an urban planning exercise. They don't give a shit whether or not it's a few millimeters off. Someone down the line, a civil engineer, is going to design a nice curb that just does the right thing. It's cheap. It doesn't hurt people. People don't trip on it. All of that type of stuff. We don't need to worry about that here. So that few extra millimeters is going to eat into the sidewalk and eat into the road or the gutter, all of that type of stuff. So let's not worry about that too much. And look, they haven't put any form of dimensioning on this wacko curb here. It's almost as if they've just drawn a 45-degree angle. We're going to draw something straight. We're not going to draw that curb though. That curb's going to be drawn when we do get to the curb section, right? What we're doing is we're drawing the sidewalk. Okay, so we've got our end point for our sidewalk, and we've got a start point, and that start point's always going to be 0. So that's going to throw in here. And we've effectively drawn a straight line, a very complicated straight line, okay? There's one thing that we haven't done is we haven't factored in this index of the closest gutter. Actually, that should be that guy. We haven't factored in the gutter is to the left or right. So it's either left is true and right is false. Yeah? So can anyone think of how we could factor that in? Like what could we do to our curve? We could mirror it if it's true. No, if it's false, we can mirror it. Another thing we could do is we could times this value, the 1 that goes in that 1 in 40. We can times that by a negative or positive number based on false or true. And the only reason I want to do this is just so you guys can abstract booleans into something other than just a boolean. Okay, so and this is where maths comes into play. Booleans can be described as true or false, or as the numbers 0 and 1. Can you guys think of the algebra? I want you to cast your mind back 3 years ago, maybe 4 for some of you, and maybe 5 for some of you. 5 years ago to when you were doing maths in high school. What would the algebra function be to turn 0 and 1 into, if it's 0, it's negative 1, and if it's 1, it's 1. I want you to do it yourself. Do it. We can do this in an expression.
Sorry, can you come again?
So, the number 0 will end up in the function equaling negative 1, and the number 1 will end up in the function equaling 1. So 1, nothing happens to 1s, but if it's a 0, it becomes negative 1. And you have to do it with algebra.
So I can't do this.
No. Just this will be a useful little exercise. It's not complex. I'll start writing it in 20 seconds. Leo, do you know what it might be?
Sorry, I was.
What's an algebra function that can turn 0 into -1 and 1 into 1?
Algebra function.
Yeah.
Okay.
Just have.
Matrix count?
Pardon?
Matrix? Do we use matrix in this?
A matrix. We don't need to use a matrix. Someone's talking to me.
Do you want me to give answers?
Yeah, sure.
Give me 1 second.
Okay.
So 1 plus x times minus 1
1
plus x times minus 1. Sorry, x times minus 1 in the bracket.
x times -1. Yeah.
Sorry, x times minus 2 plus 1.
Okay. Yeah, that's very similar to what I'm going to do. But yeah, that works. You can simplify that a little bit with although that does make 0 minus 1. I mean that makes 0 1. What you want to do if you want it to be the other way
Yeah.
is you go x times 2 minus 1.
Yeah.
That's it.
Yeah.
It's that simple. Now, the reason I'm saying this is that a lot of people, they forget algebra. They've go, oh, I don't need it anymore. Only statisticians and mathematicians doing like they're trying to work out how to invert a donut without having it intersect itself need algebra, and that's not true. We use it all the time, and it's useful here. If you can think that little function up quickly in your head, you don't have to code if-then statements. You can just go, oh, minus 0 and 1 equates to minus 1 and 1 with x times 2 minus 1. Super easy. Yeah?
For larger functions, it's quicker as well. So.
Yeah. And so if I throw this particular maths function, remember what I had here? I had the number 1 in there. If I throw that in there now, if we are left-handed for a gutter, it'll slope towards the left hand. And if we're right-handed for a gutter, it will slope towards the right hand. Cool? Now we've made a sidewalk. So, this is now effectively the piece of code, one of the pieces of code that we can put into our space syntax, into an enemy. Fortunately, because of the way that we're writing this, because we've said that this is going to be a mirrored scenario, we can also make this run if it's a lane. But car lanes have a different slope. So we can either do one thing. We can check within this code if it's a sidewalk or a lane, or we can say, hey, just copy this whole thing here. This is the lane code. I can't honestly remember what the slope of lanes, like car lanes, should be. I don't actually work on them that much. But let's just say it's 1 in 32 instead of 1 in 40. Leo, do you know off the top of your head?
I can't remember either.
What I do know is that they're not allowed to be linear. So this particular diagram that I've drawn is not actually allowed. It's actually more like that. But what I also know is I don't care at the moment. This is an urban plan diagram. We can just ignore that. We can just draw straight lines. It doesn't matter. So, just so you know, roads can't be angled ramps. They have to have a camber to them. I think it's to do with the way cars, specifically trucks driving on them, if they're angled a certain way, those trucks will just tip over the instant they go to turn on that road. So it's for safety reasons. It's not my responsibility or yours to work that out. That's a civil engineer's job. So unless you become a civil engineer, we're good. And you'll have to do that degree anyway to even get into that sphere of work. So maybe next year we'll have civil engineers in this class. And then they'll be like, it's got to have a camber of x squared plus y, and I'll be like, yeah, okay, cool, you can code that. We're drawing straight lines. Okay, but what we've got here is we've got a bunch of declarative functions. We've declared the code for making a sidewalk, and we've declared the code for making a lane, and really the only difference between them is that 1 in 32 or 1 in 40. But so what ends up happening here is when we iterate over our anemone code, anemone needs to say, okay, I've hit this first item. What is it? It's a blah. Okay, I'm going to send sidewalk off. We're going to run the sidewalk code. Oh, we've hit lane. Okay, we're going to run the lane code. So we've got a bunch of strings, these guys. Lane, sidewalk, gutter, lane.
So, what's the actual reason we're doing this rather than like a linear script, like the looping?
Because what
What does that give us?
what it gives us is the ability to write that, and it's done. If you've got a linear code, you're going to have to go copy and paste the sidewalk script and throw it at the end of your code. Does that make sense? Because the thing is, what we're trying to do is code something that allows for variability, and that's what, to be honest, that's what all Grasshopper is for, right? We want to be able to make something variable, and having a code that has a bunch of sliders that you can go, whoa, the door's bigger, right? Or the lane's bigger, or the tower's twisting. That's great, but what it's inferring is there's a bespoke element to your script. Your script is not reusable. If you can write your script so it's reusable, so we've made a script that, we're going to make a script that makes a street section, you've effectively saved yourself having to copy and paste and recode that every time you come to it. So let me give you an exercise, just a quick break exercise before we move into the next stage. And this will, I don't think I asked you to do this in the test. If you just draw a hoop like this. Oop. My bad. Doesn't really matter too much, but let's do this in 3D. Draw a hoop. If I said, okay, write a code that divides that hoop evenly and divides that other hoop evenly, let's say 20 points each, or 21, divisions of 20, and draw a line between each corresponding point, what would you do? You want to talk it? You guys want to talk it through? Yeah. Okay. So talk me through it. It's really simple. You guys should all be able to do it in front of you. So grab a curve component.
Yeah. Set one. Or,
Yeah. Okay. Set one curve. Then what?
the other curve too. Or you could put them both in one.
Just keep going. Keep going with this method.
Divide curve for both of them by whatever we want, 20.
Yeah. It doesn't matter. Yep.
And then line AB point.
Yeah. Cool. And this particular method of coding allows us to change the number of divisions, right? Whoa. Cool. Doesn't matter. How many we want, we plug it in and it works it out. Yeah? But what if I said, and now that you were already thinking this way, right? Which is good. It means you guys are actually thinking in a slightly more advanced mode of coding. What if I wanted 3 curves? And I want to draw a straight line from this one to this one, and a straight line from this one to this one. If you've coded it this way, you would probably do this, right?
Yeah, it's not like a loop, it's just...
Yeah. You would go, okay, here's that one. Okay, we've done 3. And then if I said, do 1,000. Well, you can, but you have to copy and paste those 1,000 times, right? So what you've done is you've effectively, like this copying and pasting, we'll say that's the easy part, right? But in Grasshopper, we've effectively coded in a way that meant that we still have to do something manual in that coding environment, which is the copying and pasting of each of those things. Now, you were right in the beginning to say, hey, we could technically just do multiple on that, and then rather than setting a straight line, what can we do? Not shift list. Okay, well, you can just flip your matrix, right? If you flip your matrix and you draw a polyline along that flipped matrix, you'll get the same result. Like we'll need to explode those curves to get those as like individual straight lines. But this method of coding actually ends up giving you a more versatile way of variability and robustness for your code. And that's what we're doing here, right? We could very easily go and draw this manually. We could very easily go and draw that using blocks of code in Grasshopper, just block, 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 block. Sidewalk, gutter, laneway, median strip, laneway, gutter, sidewalk. But if we can just give it a set of instructions and it gives us our curve, that's the best result. That means you can give this to someone who doesn't know how to code. They just need to know how to write the syntax. And they will pay you for it. Yeah? Yeah? So, like, I've written codes that took me a week to write, and then I have provided services to initiate those codes for private clients, and I've charged them a week's amount of work each time I run it, and it only takes me 5 minutes to run.
Is that real?
Yeah.
That's true.
The most lucrative part of my career has been working privately, doing freelance work for companies that have no fucking clue what coding is. Okay? And as long as you can convince them that you're doing good work for them, they're willing to pay a week's amount of work, and it only takes you 5 minutes. That's fine. Okay? So yeah, I've done 5 minutes work and been paid like $2,000 for it. The thing is, you have to find the right client.
Can you teach that in this studio?
No, it's hard. And as well, that's competition against me. It's bad. I want those clients. I've only got a few of them. The best thing to do, but this is the thing. Think of it rather than that as, look, you've just created value for you, value for your team, value for your employer in this.
It's like the same business model as like a YouTube video maker or something. Like you upload once, you keep getting paid.
Yeah.
As long as you just service that relationship.
Yeah, and to be honest, if you put in more effort, if you provide this as rather than as a service, you provide it as a product online somehow, then you don't even have to do the work. You can get them to put in the text, but then they usually go, well, I only want to spend $5 for that. The instant they talk to a person, it's like, well, I work for $150 an hour. They go, okay, here's the money, right? So depends on what you want to achieve, and this really isn't about. I'm not saying this is about making money, but it is, right? At the end of the day, we are trying to survive. We're trying to put food in our mouths, and we need to do that by making money. And the people that we're working for want to make more money. They're in business to make a profit, and so basically, your value to them is making a profit. How are you someone who can make someone else profitable or provide a service to someone that is good so that they can make money, or make a space good? So like I very much sit on the fine line between design being, oh, we've got to make the world better and and we've got to, because I do believe that that space and geometry can intervene in a place and make that place better, but at the same time that also needs to somehow generate money, because if it doesn't, then who's going to pay for making that space? So there's that in between thing. So I might come across as very commercial at times, but at the same time I'm a massive.
I don't know, it's kind of like refreshing after all our other teachers, because we just sort of get like bullshit down for the rest of the time.
But this is the thing. They are doing the same thing. They are literally teaching to get paid.
Yeah.
Yeah? You're paying me.
It kind of hurts how like obvious what's happening is.
Yeah.
Like how much, like we pay $100 and whatever it is, $20. A lot of people in this classroom a lot more.
You're paying more than $120.
Yeah.
It's about, for the Australians here, it's $1,000 a course.
Yeah.
And then for the non-Australians,
Oh, I mean like physically, like just coming in the door and sitting, like this little bit of time is like what, $100. It's 10.
yeah, I wish I got that $100,
Yeah.
but I don't. I only get a small portion of it.
You're earning it. The others sort of just get it. Same.
I'm earning it, am I? That's nice to know. I'm teaching something. That's good. No, they're doing something. Look, even if a teacher is not teaching you anything, just use that course as a way to try something out. Use it as like someone is there judging you at one point, and there's a bit of pressure to get things in. Use that, even though it's not worth the $1,000 that you're spending. It's better than. Look, you'll end up probably pushing yourself further than if you were just setting yourself that challenge at home and there wasn't that sort of incentive or judging eye over it. So that's my defense of the teachers that you don't think they're doing anything. I don't know if they are or they aren't. I have to do this course to find out. I only know what I'm teaching. So from what I do know though, the students that are coming out of this degree are good. So someone somewhere in this, other than me, is doing something right. No, they're still around. You'll get there. Look, you're following along here. So that someone's done something right. Christina's done something right, even just a little bit, right? If you're able to follow me at the moment, because I'm not teaching this for beginners. I'm doing this at a much faster pace. Okay, back to this. So you understand this idea? Very simple little exercise that teaches you that just the way you code things can drastically improve the time it takes to code it. Actually, that's probably less components than the A to A one. Yeah. So it's even faster than even the first example. Okay, we're here. We're in our iterative anemone code. We're telling this code to iterate over a list. We can plug that list in. It's not going to do much. This is probably actually the wrong thing. What I'd rather just have is something like this placeholder, like 10, plugging 10 in. So when it runs, it's actually just running and creating this counter, that C value. So this 10 basically needs to be the length of our list. It needs to be 5 or whatever, a variable number. And so if we were to pick out what we're working on, we can use this list item using the C value for I, and that will tell us, okay, currently we're running on sidewalk. Okay? What I'm going to do is I'm just going to chuck a number slider into the N value for an enemy. What that is doing is it's just going to let us manually control how deep into the code we are. So right now we're at the 0th item, the first item. And if I just drag this up, it'll iterate through the rest. And if I drag it back down, we need to reset it. Because that number there is number of repeats, number of runs. So we're just going to focus on the first one. So we've hit sidewalk. We need to know what function sidewalk is. And this is why what I mentioned before is kind of bullying Grasshopper. We've declared the function sidewalk. And now we need to say, okay, we've hit this function. How do we send a signal to this code to tell it to do something and send it back into our anemone script? We basically need a lookup table that says sidewalk is our first code. Our second code is lane. And we'll say our third code is exclamation point, even though we haven't coded that yet. So that's our list of functions, function 0, function 1, and function 2, which we'll do in a minute. And then we can use that member index to say, what am I doing wrong? That's what I'm doing wrong. Member index says, okay, we've hit sidewalk. That means we want to run the 0 function, the first one. So we can't declare functions in Grasshopper, and Grasshopper then goes and grabs the code that runs that function, runs it. Instead, we have to say, look, it's that index, or dispatch it to that part of the code. Do you know what I mean? It's actually probably one things that annoys me the most about visual coding is that it doesn't have declarative functions, and you end up talking to computer scientists and you go, yeah, I code in, so what's your primary coding environment? Grasshopper. And they look and they go, this isn't coding. It doesn't even let you do declarative functions. Like, that's the basic terms of any other coding language. So we're saying we want 0. 0, in this case, the output of each of these is going to be an item. And right now we'll just make a piece of geometry or whatever. So we're going to say, for this particular guy, these will all just be a single piece of geometry, a line. So a line coming out of our sidewalk, is going to go into a merge, and that's going to be item 0, right? Then a line coming out of our road will be item 1, and then this is how simple the code for our gutter is going to be. We are going to have to put a number on our gutters, by the way. That gutter is going to go down, 0 is down, and 1 is up. If we're going to draw a gutter, we're going to draw a straight line that goes vertically. Oop. This is all from the origin point. Geez, so many meetings today. And the length of that line is going to be 150 millimeters by default, we'll just say. And because we're doing this in meters, that's 0.15. There he is. And the number that we're going to be plugging into this is like -1 or 1 or whatever, and so that's going to be the dimension that will go into the y value, and so that will send that gutter either up or down, right? And that's going to be our third geometry. This is not the most efficient thing. What we're actually doing is we're cheating a little bit. We're actually getting Grasshopper to generate a sidewalk, a lane, and a gutter, all at the same time for every run. And then we're telling Grasshopper, just pick one of them. Pick the one that is a sidewalk, or pick the one that is a gutter, or a lane, depending on what the string is. We could make this a little bit more efficient and say, like putting in gates and whatnot to run these codes so that when we do hit sidewalk, only the sidewalk code runs, or when we hit lane, only the lane runs. But because these are so simple, like we're literally drawing a straight line, we don't have to worry about it too much. But if you ever intend on using this in a more advanced way in the future, just know you can put dispatches, true false dispatches at the beginning of each of these little declarative function zones so that only they run when you ask them to run. Like you might have a code that takes 5 minutes to run and you have 10 of them. You don't want them all running each time, one after the other, because that's gonna take you like hours just to do something really simple. So just be mindful that we're being rather lazy with this. So we end up with these need to be flat when they come out of their scenarios. We plug that into a list item, and we're telling that list item to which declarative system we want. So we want item 0 from that, and that's going to give us our sidewalk curve. There's our sidewalk curve. Right? Is everyone following along? Okay. Okay. So, this is where, so how do we actually make these things join up? And this is where anemone comes in handy. If I want the next thing that comes along is going to be our gutter, right? So if I throw that into a 1, that's going to hit the gutter geometry number 2. We're going to come along here, and that's going to give us, why is that giving us the wrong thing? 1, 2, 3, 4, 5. 1, 2. Why do I have 2? Because this isn't sidewalk. That's right. I need the C index to be. So we need to start see this anemone C index. This is actually now going to take that value, and it's going to take yeah, cool. So that C index is now being plugged into those. So we should end up with one line, which is our gutter. But what happened to our sidewalk? It's gone. Right? So anemone can store geometry from like through the loop. You can actually go in, if you zoom in, you've got that little black plus there. That lets you add more variables to the system. It errors because we need to add it to both, so we need a D1 on both sides, like so. And if I plug my geometry output into that, and we just rerun that code, then at least what's happening is it's taking this output and it's chucking it into D1, and D1 then will get it out here. So we actually want to merge these two guys together. And that'll give us both a sidewalk and a gutter. Can anyone see the problem? Pardon?
It's on the wrong side.
It's on the wrong side. Yeah. So what's happening is I'm drawing all of these curves off 0 as a relative point, and we want to do that because it's useful. It means that when we do that 1 in 40, that we can just put a plane a certain distance away from our sidewalk, like 4 meters, and then do the intersection, and we don't have to measure. Okay, is it at this point? It's always relative to 0. What it means though is if we join our curve prior to it getting merged, and we throw in an endpoint. Endpoint would be a 1, not a 0, and because we're using percentages, we always need to make sure we reparameterize. There's our endpoint. This gutter curve, or whatever we use, it can be moved. It can be moved using that endpoint as a vector. You right, Tom? Cool. Just making sure I wasn't being boring. Okay, so if we use that point as a vector, vectors and points are literally the same thing. That will move, because we're going from 0, that also literally just moves that gutter line to wherever it needs to go. And then that can be the line that gets merged in, and we just need to make sure this is all flat. So the output of this, actually, let's do the join after the merge. That will guarantee flatness. What that means is for D1, out of anemone, we end up with this polyline curve. And I'll just hide everything but that polyline curve. So that's moved the gutter to the end. And then if I run to the next line of, that's running the that laneway. Right? And the reason the laneway is going the wrong way is because we've got a gutter on either side and it's just happened to pick the one on the right instead of the one on the left. But look, we'll run it to 3 now, and that'll put a gutter there. And then there's our sidewalk, and that's going down to the gutter. Cool? So if I throw these strings together properly, sidewalk, gutter going down, then a lane, then we'll just get rid of these guys. We run into a problem. This guy's got nothing in it, right? The only reason it worked before was because we added that code after it had generated that line, and so this point just doesn't exist. It's nothing. So what we will need to do is just make sure that if this ever equals nothing, if we throw that nothingness and something, as in just a x, y origin together, and pick out the first item. So if the first item does exist, it'll ignore this placeholder one. That's all we need as our vector to move our curve and get our geometry to work. So I'm going to reset this. We should end up with, what's going on? It's broke. And we also need a clean tree before we put that into a list item. That'll get rid of that null. That'll give us that origin point. It moves the curve to the origin. It merges that with nothing. It joins it, plugs it back in, and so if we iterate along our loop, we end up with, that shouldn't be that, but yeah. it should only run 3 times. So if we plug that in and just start it one more time, hiding everything but the last thing, we end up with our street section, half of it at least, right? Does that make sense? The reason this is double is because this needs to be x minus 1, I think. It's 3 long, but we only want it to run up to 2. Okay, we're almost there. I want my lane actually to be 6 meters, not 4. Changing that doesn't work, right? That's not 6 meters long, that's still 4. And the reason is we're actually, that number 4 here is not a variable, right? So it's fixed at the moment. At the moment, we're picking out the function sidewalk, gutter, lane, and that's coming from index 0 from this list. If we copy the list or add that little +1 to the bottom of the list item, that will give us the dimensions 4, 0, and 6. And so we just need to grab a list item for the loop, which will then tell us on this particular part of the loop, which is the road, the dimension is 6. We just plug that into all the arguments or variables that define our geometry. So we care about 6 here, and we care about 6 here, and we also care about 6 down here in this -1 and 1. That's fine. It will only be a 0 or a 1. Sorry, a 1 or a minus. Ooh. We will have to turn that into a -1 or a 1, won't we? X minus x times 2 minus 1. Done. And so now those variables are plugging in. If I change my input, so if we make this 1, there we have our gutter going up, and you can see our road's now 6 meters wide. We can make our road 10 meters wide. We can make our sidewalk 2 meters long. We can add a gutter on the other side of that road. Actually, we could just do this. We could put 2 roads in, so lane 4, and then lane 4, and then a gutter that goes up, and then another sidewalk, which is 2 meters wide, and we'll make this gutter go down, and there we go, we've just made a street section, right? Just by typing in some syntax. Cool? Sorry, you're making like a what the fuck face?
It's amazing.
It's amazing. Okay, cool.
No sliders or anything.
Huh? No sliders? It's just syntax.
Crazy.
It's just syntax.
Totally different from what we learned last year.
Yeah, and that's, if I was just teaching you what you learnt last year, then there's no point to this class, right? Yeah. So there's a space syntax that we've just written. You can now go and add other things, right? If we added a median strip, that's going to have its own type of code. If we're going to have planting, if we want to represent this planting, we would want that to actually place some geometry there. And that gets a little bit more complicated, right? At the moment, all we're doing is we're drawing lines. Now, I did say there's a mirror at the end, right? So, and that mirror sits in this little function right here. It spits out that, there's the mirror. So, you guys can do this any way you want. You could literally write your own another anemone that runs after this that runs through a list of special functions like put plants in, mirror it, twist it, do whatever. But in this case, we very rarely need to do anything other than mirror a street section. So we'll just throw in a, now we will do that regex function. We'll just search for the word mirror in this string. So there's that string, we'll just bring it over here to the very end. Search for mirror in that, and if it is true, take our polyline curve. Get the end point of it. That's not end. I don't know why my brain thinks 0 is end right now, but for some reason it is. Throw a XZ plane at that point, and then mirror your curve. And because we're doing an if-then statement effectively, we can weave that back together again with that true-false. And then there is your space syntax all coming together. Oh, actually, we just want to join those two together as well. Cool. So if we throw mirror at the